Alright, so this video is going to be over determining the product for precipitation reactions and understanding when they happen, when they don't, and writing net ionic and complete ionic equations for them. Alright, so the way that I'm going to do this is first we're going to determine the product, and then I'll go through how to write the complete ionic and net ionic equations. So the first thing you have to do when you look at these, they're double replacement reactions. They're one type of double replacement reactions. And for precipitation reactions to form, they have to form something called a precipitate. And a precipitate is an insoluble substance. So it's something that does not dissolve when it's in water. And so these right here are salts. They're ionic compounds, they're salts. And so they're solid in nature, but in order to get them to react with each other, we have to put them in water so that the ions can interact with one another. Because remember, if it's soluble, the ions split up. So I'm going to draw a little picture here. I'm going to erase this this definition. I'm going to erase this definition. So if you want to write it down, pause it so you can write it down. All right. Okay. So if you were to put this in water, so I'm going to draw a little test tube, and then draw another little test tube. If silver nitrate gets put in water, right? Well, nitrates are always soluble. And so this will dissolve. And when it dissolves, we're going to make one silver ion and one nitrate ion. Okay? Of course, you'll have way more than that, but you get the point. It'll be 1-to-1. And so this is in water. And if lithium chloride gets put in water, it's also soluble because it's got an alkali metal in it. So we'll have lithium and chloride. All right, and so this plus sign then indicates, this one right here, indicates that we mix these two things together, right? So if we mix them together, let me see if my eraser will work. Of course not. We'll end up with something like this. And so lithium could go back to chloride, but it's not going to form anything because it's still sitting in the water. It's just going to stay dissociated. The silver could go back to nitrate, but it's not going to form anything. It's just going to stay dissociated. But when the silver and the chloride meet each other, they form something that can't dissolve. They form an insoluble substance. And so they're instantly stuck together, and they form a precipitate that precipitates out a solution as a solid. All right? And so that's how these reactions happen. And we usually label stuff that dissolves in water as aqueous because it's dissolved in water. So these two things dissolve in water, AQ. And then we would end up getting silver chloride, and we would label it with a small s, showing that it's the solid. And then, of course, we have lithium nitrate left over. So we put those two things together, and we show that that's in water as well. And so what we would have, this right here, with this silver chloride down here at the bottom, is represented by that, where we have silver chloride solid sitting at the bottom in a lithium nitrate solution that's in water. All right, so I'm going to move this up now. and we'll write the different equations. All right. So I'm going to rewrite it down here. So I have silver nitrate, and that's aqueous, plus lithium chloride, which is also aqueous, goes to silver chloride, solid, plus lithium nitrate, aqueous. All right. I know my handwriting's bad right there, sorry. So the silver nitrate dissolves, right? So it makes silver ions and it makes nitrate ions. And then the lithium chloride dissolves and it makes lithium ions and chloride ions. And then we get silver chloride as a solid. It doesn't dissolve, so we don't split it apart because we're showing right here where we have them split apart that it's dissolved. And we get a lithium ion and a nitrate ion. Okay, now you can label these ions aqueous because they're in water, but you don't really have to. But this one you can't split apart because it's not going to split apart in water. It's going to be a solid. It's going to be a precipitate. And so this is what we call a complete ionic equation. I've also seen it total ionic equation. Okay, so it shows all the ions in the solution, and it shows the precipitate. All right. So now I want to talk about the ones that aren't doing anything, the ions that are not doing anything. And in this particular reaction, we have nitrate on this side, and we have lithium on this side. And we also have lithium over here, and we have nitrate over here. And those guys are not changing at all. They're the same thing on the reactant side as they are on the product side. Whereas silver and chloride have changed. Here, they're dissolved in water, floating around. Here, they're a solid sitting at the bottom of the test tube or flask or beaker or whatever you've got it in. So a chemical change has happened to them, right? Now these that aren't doing anything, they're called spectator ions because they're not doing anything, they're just watching. So they're not changing in any way. All right, so technically, since they're not undergoing the chemical change, they don't necessarily have to be part of the chemical reaction. And so another type of reaction that we write would just be the production of the precipitate, where we have silver ions plus chloride ions, and that makes silver chloride. So it's the same reaction without the spectator ions. And this is called the net ionic equation. And the net ionic equation is just like your net pay when you have a job. It's after taxes and insurance and everything else that they take out before you actually get to take home your paycheck. So it's net. It's what's really important to you. All right, so let's try another one of these examples and see how it goes. All right, so in this one I've got sodium phosphate reacting with lead 2 nitrate. And so first I want to see if I'm actually going to make anything or not, right? And so I've got sodium ions, and I'm just going to write the ions up here, plus, and I've got phosphate, and I've got iron 2, and I've got nitrate. So if these switch, inside goes with inside and outside goes with outside. So I'm going to end up with sodium nitrate, which would still be soluble, right? Because alkali metals are always soluble and so are nitrates. And I would get iron 2 phosphate. Now that is not on our solubility rules, so we assume that it's solid for right now, okay? So I'm going to rewrite the reaction down here. And sodium phosphate is aqueous because the sodium is soluble always. And then we have iron 2 nitrate. And that is also aqueous because nitrates are always soluble. Okay. And so then I get iron 2 phosphate. So remember, iron has a 2+ charge in this compound, and phosphate's -3, so we have to do a little crisscross. So we get Fe3, PO4 2, and that's going to be a solid. And then we get sodium nitrate, and that's aqueous. All right, so this is our normal equation. We need to balance it real quick. So I need 6 of these, 2 of these, 3 of these. And so that's balanced now. So now I'm going to write the complete ionic equation. Remember, the complete ionic equation, we break up anything that's aqueous because it's dissolved in water. That's what aqueous means. It's been dissolved in water. So I've got 2 of this whole thing. That means I have 6 sodiums and 2 phosphates. So 6 sodium ions, and I've also got 2 phosphates. And then I have 3 iron 2 nitrates. So that means I have 3 iron 2s, and I have 6 nitrates. And that's going to make an iron 3 or iron 2 phosphate. It's a solid, it's not dissolving, it's precipitating, it's the solid at the bottom of the flask. And I've got 6 sodiums and also 6 nitrates. And so I'm going to go ahead and circle my spectator ions. So this is the complete ionic equation, and it should be balanced. If you balance the molecular equation, the equation up here, correctly, you should get this balanced back. So the spectator ions here are the sodium and the nitrate, right? Because they're not changing, they're just watching the reaction occur. And so the net ionic equation, this is the net ionic equation, is 2 phosphates plus 3 irons goes to iron 2 phosphate. And I just want to mark that this one up here in blue is the complete ionic equation. All right, let's do a couple more. Now this one that I'm going to do is a little bit different, and I'm going to do this one because I want you to see what happens when the reaction doesn't occur. So if we have lithium bromide and sodium sulfate, that's going to end up making lithium sulfate and sodium bromide, right? They're going to switch inside with inside, outside with outside. So you get this, and they're all aqueous. This is aqueous, this is aqueous, this is aqueous, and this one's aqueous. So they're going to dissolve, all of it. So when we have our big container of this stuff that's mixed together, right, we end up with a lithium ion, a bromide ion, a sodium ion, or 2 sodium ions actually, and a sulfate ion. So in this solution, we have all these in here. Well, in the product, it's the same thing. Nothing has happened because none of these ions in here none can form a precipitate. And if they can't form a precipitate, then it can't be a precipitation reaction. So this is no reaction. Nothing happens. Your complete ionic equation is going to look identical on the reactant side as the product side. So if I write that all together, it's going to let me move this up. If I write it all together, it's not going to let me do it. All right, I figured it out. So, well, I kind of figured it out, didn't I? Here we go. What the heck? All right. If I write this all together, I would have lithium ions, right, because it's aqueous, bromide ions, 2 sodium ions, a sulfate ion, and then on the product side, I have, you can kind of still see it up here on the top of the screen, I have lithium sulfate and sodium bromide. Well, I'd have 2, oh, I didn't balance the equation, did I? 2 and 2. I have 2 lithiums and a sulfate and 2 sodiums, 2 bromides. And so it's the exact same thing. Nothing happened. No change. And in a chemical reaction, you have to have a chemical change, and there's not one. So all we did was mix this stuff together. All right, so in a precipitation reaction, before you do anything, you should check to make sure that something forms a solid. Otherwise, you're kind of wasting time. Not that that's a bad thing, but everybody's time is valuable. So here we go. Let's do one last one. All right, we have calcium nitrate and lithium carbonate. And so I'm going to check to see if I get a precipitate. Lithium nitrate would be soluble. And calcium carbonate, well, that's not soluble. So that's going to be our precipitate. So I'm going to rewrite the reaction down here. Got calcium nitrate, and that's aqueous because nitrates are always soluble. And then I've got lithium carbonate, that's aqueous, whoops, because lithium's an alkali metal. I did it again. Something's wrong with my hand. It's not listening to my brain. And then I get, as a product, lithium nitrate and calcium carbonate. So I've got calcium carbonate and lithium nitrate. Now I need to balance this reaction. Oh, this one's a solid, and this one is aqueous. So I need to balance it. I need 2 of these because I've got 2 lithiums and 2 nitrates. And so this is my molecular equation. So now I need my complete ionic equation. So all the aqueous ones turn into ions. So I've got a calcium ion, and I've got 2 nitrate ions, and I've got 2 lithium ions, and 1 carbonate. And then I get calcium carbonate as a solid, plus 2 lithium ions, and a nitrate ion, 2 nitrate ions. And so next I identify my spectator ions, and my spectator ions are going to be nitrate and lithium because they're ions on both sides. And so that's my complete ionic equation. And And then from my net ionic equation, I get rid of the spectator ions, and so it'll just be calcium plus carbonate goes to calcium carbonate. And so this is my net ionic equation. All right, so that's all I've prepared for this one. I think it's long enough. If you need more help, leave a message and I'll be glad to make a couple of more examples of this. I know it can get confusing, and I only know that from teaching it. I don't remember, it was too long ago when I learned it. I don't remember if I struggled with it at all, but I can tell you, if you're struggling with it, it's probably because you don't know the charges to the ions, number one. Number two, it's because you don't have the solubility rules down yet. So as soon as you learn those solubility rules, this starts happening a lot faster. You start to see certain things that make precipitates easier, and you also, so you start to get a feeling for it. But not knowing these ions and what to write down and having to think about it every time or check a periodic table every time you write down calcium, that takes too long. So you really need to take the time to memorize them. It'll save you tons of frustration in the end.